Okay, so this is gonna be day 14 of Everybody Copes. Okay, so I guess this is just simulation. Um, There's actually like patterns that form. This is pretty crazy if you ask me. Alright, so I'm guessing let's first like validate I understand this. So I'm guessing I should like make everything just everything sound like that. Actually, we're gonna have to read. My bad. I don't see that bad. I don't know. Actually, yeah, they're probably like talking about like this piece over here. So there's like these guys, and then it goes like that, and then like each has. Oh my god, I lost it. All right. So what does like center mean in this case? I guess so. This is still like an 8x8 probably. because otherwise it won't make much sense. Alright, it's still an 8 by 8. So I'm guessing that center like means so what's this, right? It's like 34 by 34. It's like 33, right? And this is like 0, 0. So I guess like the center along this line, it would be, so it's like 34 elements, which is an even number of elements. So there's no like exact middle, but so what you're trying to find is just like one of like the coordinates, right? So you can think of it like a one-dimensional array that has like 6 elements, and then you want to find like the middle, which has like 2 elements, right? So you can do like, so it's got like 6 elements, then the length of it is 6. So if you do like 6 divided by 2, then that you get 3. Right, let's do it with even less, right? So let's do it with like 4 elements. Then you're interested in actually getting the output of like 1 and 2. So the way you do that is, if you look like straight down the middle, by straight down the middle, you mean like 4 divided by 2, and you subtract like the 2, and then you add 1. So let's say if that works in general. So you do 34, you divide that by 2, and you subtract the 8 and you add 1. So if you do this, you get 10. Now the idea is this like 10, right? I mean, let's just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, so it looks like I'm really bad. Like, so that's like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, so this looks like 13. Oh, you have to like subtract 4, I guess. Yeah. So it's like 13. So it's like 13, 21, right? So it's 13, 13, 21, 21. So you just have to do like this over here. So you get like you know where to match it, essentially, right? So like, where should you start matching? You should start matching it like 13, 13. So like, match I and match J is just like n, divide that by 2, and just take So you're like trying to find to see if there's like some regularity to it. So maybe what you could do is just do something like so we're not gonna get to probably like how much is this? It's like 1 billion rounds. And we're moving way too slow to get to like 1 billion rounds. So what I'm thinking is that we just take this and we look like, for example, at like differences, or like we try to like investigate some pattern. We should probably use logic to do that. Like probably be much more effective, but I want to look like at differences, for example. See if we notice anything unusual. Yeah, it looks like we do. So this is just like the way you solve it, I guess. So you can see that it's like you first find one at 125. So okay. Okay, so reasoning goes like this. It's like you first find one at 125, 25, then at 125 plus 10, plus 892. So let's make sure that's like 1017. So you do yeah, and then you have to do like 125 plus 892 plus like 3203, and then you get to like 4220, right? So I guess now the question would be, are these actually like I mean, how many active things does it have? Because that's like what you're interested in, right? So you know that you're like at this specific round, but let's also just print. So let's just like print, I guess, I, and print just count active of the matrix. Yeah, so you see it's like 528, 588, 552. So you know that the pattern most likely repeats itself, so it's probably the exact same pattern. I guess that there's also the chance that it actually doesn't repeat, and you just have it. I don't know, maybe there's even like a nice way of like proving that it repeats. But anyways, you see that you get like this really, really nice thing. So you can just sum this up, because you get like repeated stuff. And that's it, I guess. Alright, so let's just come up with a nice formula to sum this up and just wrap the day up. So yeah, I'm guessing, so it's like at 125, so at 125 it's like 552. So it goes like 552, and then you go like 588, and you circle back again. So Okay, let's like pose this a little nicer. So you play 1 billion rounds, right? Let's just say you play in general, like you play Y rounds. So you have like after round 1, after round 2, after round 3, all the way up to after round Y. So you know in here that you have like certain numbers, like you have like 125 and then there's like 892, and you know that these map to like 552 and 588, right? And then if you want to get from like x1 to x3, so you want to get from this to that other one, then you have to add up. It's like you add up 892 with 3203 and you get to this one. So I'm betting it's this formula. So I'm just betting it's this formula right here, right? So is it really? I have no idea. So you know y is 1 billion. Okay, I'm an idiot. Yep. So this looks good and this looks fine, right? So you get like um this is like your cyclic type of references. You just sum this up, right? So this is like your anyways. I think you get the point. But let's say you have something like something like this. Okay, so what I'm interested in is just at first let's print rounds. So let's do, we're gonna do this again, and then we're gonna do the exact same thing. Okay, so you can see that we have like a lot more numbers until we like start repeating ourselves. So this is what I was like thinking, maybe there's like a lot more numbers until we start repeating ourselves. So there is really, so there are like a whole lot more numbers, right? So there's like 140. Okay, let me just copy this because I'll like right, so it's like everything up to 142 and then they start repeating. So the differences between them, so I guess we have to do like the exact same thing. I'm just doing it manually. I'm pretty much just doing it by hand, which takes like a lot more time. Looks like I just fucked this up extremely badly. That is amazing. And add the, oh my god, I didn't add like a lot. So you take to like including 507 and you get to like round number, so you get to this like you get to like 2204. So you're interested like what these numbers are, I guess. I mean like how many like active things are in each of them. And then you want to know like the sizes of these sets. So essentially what you do is you just add up. So if you add up from like, so if you add up all of this, and I guess you add like, so you start like at 183, right? And then you start adding this. So if you add this entire thing, you get to the last one. And then what would the next difference be? Oh, it would be just 2074. So right, you just want to add like this and add 2074. So this should hopefully like give us 4278, which should be like the next line number. Right, that's right, and that's 580. Correct. Amazing. So you know like this is then like the period, I guess. So this is like your period, and then you build multiple sets that look like say like SI is like 183 plus the period times X, such that period plus a 183 plus period times X is less than or equal to Y. So you're gonna need like SI, let's do like what would this be, I guess array at I. So you need like, you need this mapping as well, and then you need to like sum all of these up. Right, it's kind of tedious to do it by hand, but okay, let's pull this out and just do it by hand at this point, because there's like no going back. So this y minus array at I, and then you want to divide that by period. Right, so the size of this set would be divide that by period add 1, and then to this you multiply it by that. Right, so let's just define, like just leave all of this, let's just say solve. Right, so define a few things. Define your array, I guess. So Okay, so just call solve, I guess. My period is wrong. My period is still 495? How did I arrive at this conclusion then? But did I not? I should have just summed these up. Wait, what? Right. So I guess my period is still... Okay, we got it. So yeah, it just creates patterns, and you can look at those as like these sets here. So if you define yourself like a set for let's just like so if you look at this is actually cyclic. So what you get is, oh my god, this is actually, I don't even know how this script runs, right? So it's actually like this, and then there's actually this, plus period. So what I'm trying to say, okay, let me just use words, right? Let me just use words. Okay, so what I'm trying to say is that at round 183, there's 580 active things. So this is the column for round, and this is the column for active. So you can see this, and then you can actually see that there's a cyclic pattern. So what happens is that every once in period times, then this repeats itself. So what you do is you construct these type of sets here, which just means how many numbers that start with, like, for example, 183 plus period times x are less than or equal to y. So you just want to count like the size of this set, because that represents how many times this particular pattern, like on the first one, gets hit, right? If we take like I to be 1 here instead of 0, then it means how many times this guy gets hit, right? So this is like an array. This is a set of elements, and you want to like know the size of this set, and then you want to multiply that by how many active things are inside of that one, right? So how many sets do you have? Well, you have as many sets as there are like unique patterns that you can get, right? So you look at this set. If you take x to be less than or equal to this, so you just move like these things around, and then if you don't know like why is there this +1 here, it's like, imagine that x gives you 7, which then means that, so x here should be just bigger than or equal to 0. So if x gives you 7 here, which is like a whole integer, then you know that you can do it for so you can plug in anything here, like 0 1 through 1 through 7, so that's like 8 numbers, right? So you can plug 8 different numbers. So you can plug x plus 1 different numbers here, and then you get yeah, x is a whole number, so you have to include 0. There you go, right? So you just take this, and for each, so you take the size of the set and you multiply it by its respective number of active things inside of it. So this is what I'm doing. Of course, you could have like done this programmatically. I've done it pretty much manually, but it's just math anyway. So you could have done it like, you know, just build this up, and then if this guy repeats itself, then stop, then find the period, because like the period is the first time this guy repeats itself, that's the period. You give it like the period, you give it your tuple of things here, and that's it. So that's pretty much it, really. So all you have to do is just check when this guy repeats. So once it repeated once, then everything is clear, right? Yeah, I mean, this is the case, but maybe you can actually find like, anyways, this would work, but not always. Yeah, that's it.